Level 4.4, so we've made it to the final lesson of the calendar year with polynomial and rational inequalities. So if you recall back in level 3, we did have some earlier inequalities that we were solving. So it's a 5-step process for us, and it should be pretty familiar since we're going to be going again to a number line, only this time we're just trying to answer the inequality. So the process that we want to use is we first want to move everything to the left side and have 0 on the right-hand side. So no matter what our polynomial is or our rational function is, we want that to the left of the inequality. So once we do that, we want to find the domain of our rational function. And if you recall, the domain is what makes the denominator 0. And then we write that x is not equal to. Then find the zeros, which are the x-intercepts. So this comes from the numerator equal to 0. Second to last step, we put all of those things on the number line, and then we're going to test for each of those intervals if it's positive or negative. And based off of it's positive or negative, it's going to give us the answer to our inequality. So let's try a couple of these. So first up, we have a polynomial. So polynomial, don't have to worry about the domain because the domain is all reals. Okay? Second thing, find the zeros. So for us, we have x equals 5, x equals negative 2. Now we do have a multiplicity of 2 here, so I want you guys to still be able to write that multiplicity out. And then we're going to throw these on our number line. So negative 2 and 5. And we're going to test in here each of these 3 regions. So to the left of negative 2, how about negative 3? Negative squared is a positive, so we have a positive times a negative, which gives us a negative. Pick a number in between, 0. So if we plug in 0, that would be a negative squared, which is a positive, times a positive, which is positive. And then to the right of 5 would be positive, positive, so that would be positive. So where is this positive? Well, everything to the right of negative 2. So we write negative 2, comma, infinity. And we use the bracket because we are not including it. So this is a far easier thing to do than the graphing that we just did. So this is a nice little finish to our level. So next up, let's try a different color. First, we want to factor. So we're going to take out an x, and we're left with x squared minus 9. It's less than or equal to 0. We can still factor this. So this is x, x minus 3, x plus 3. So then our zeros are x equals 0, x equals 3, x equals negative 3. Our domain here is, again, all reals because the domain of a polynomial is all reals. So the last thing that we have to do, draw our number line. We're going to have negative 3, 0, and 3, which means we have 5 regions to test. So to the left of negative 3, we have a negative, negative, negative. 3 negatives make a negative. Between negative 3 and negative 1, let's say negative 1. So negative times a negative times a positive, which would be a positive. How about between 0 and 3? So how about 1? Positive times a negative times a positive gives us a negative. And then to the right of 3 would be positive, positive, positive. So I want to know, where is this less than or equal to 0, or where is this negative? So we can see we have a negative here and a negative here. So the way we're going to write that is going to be from negative infinity to negative 3, bracket, because we're including it, union, because we're joining the 2, and then bracket, 0, 3, bracket. This is our inequality. That is where this polynomial is negative. All right, flip it over. We got 2 more, and then we're done. So flipped over, sorry, I misspoke. There's 3 left, not 2. So we have our rational function. So instead of a polynomial, we have a rational. That doesn't change anything. So our domain is x is not equal to 1. And then we have our x-intercepts at x equals -1. So now we can just go to our number line. We want -1 and 1, and then we're going to test. So to the left of -1, so -2, we would have a negative over a negative, which gives us a positive. Between here and here, how about 0? We would have positive over negative, which would be negative. And to the right of 1, we have positive over positive, so that is positive. So again, this inequality is saying, where is it positive? Positive. So we can write from negative infinity, let's do green. So from negative infinity to -1, union, parenthesis. We have parentheses because the inequality doesn't have a line underneath it, so we're not including them. And then 1 comma infinity. So not so bad. How about 4? So we want to solve this inequality. So step 1, what's our domain? Our domain, x is not equal to 0. Then we have our x-intercepts, which come from our numerator. X equals 1, x equals -1. So that's all the information that we need. So we go to our number line, and we're going to put on our -1, 0, and 1. And then we're going to test. So to the left of -1, so -2, we have negative, negative over negative, which again gives us a negative. Between -1 and 0 is 1/2, so that would be negative, positive over negative. So that would give us overall a positive. Between 0 and 1, 1/2, so that would be negative, positive over positive. So that would be negative. And then to the right of 1 is positive, 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 which would be positive. So again, we look at our inequality. We want this to be, where is it negative? So we have from negative infinity to -1, bracket, union, bracket, 0, comma, 1. And we include both of those because, sorry, we don't include here. That's my fault. And then above, we should double check. Since we can't be 1 here, this should be a parenthesis. Oh, there's already parentheses. So here, we don't write a bracket, we write a parenthesis because we can never be 0. Because we wrote can't be 0, so we don't include it. Last up, fractions that we have to do a little bit of work to. So we need to get these all on the same side. So that's 5 over x minus 1 minus 4 over x plus 2 is less than or equal to 0. Now, in order to do all of our work, we need a common denominator. So this needs a x plus 2 on the top and bottom, and this needs a x minus 1 on the top and bottom. So this is 5x plus 10 minus 4x minus a -4 all over x minus 1, x plus 2. So simplifying this out, 5x minus 4x is x, 10 plus 4 is 14 all over x minus 1, x plus 2. So then my domain here would be x can't equal 1, x can't equal -2, and my x-intercepts, we take the numerator, would be x equals -14. Okay, so we have all of those. We have -2, we have 1, and we have, we have -14, -2, -1. Okay, and +1. Jeez. Finish strong, Mr. Swenson. So, to the left of -14 would be a negative over a negative, negative. So 3 negatives make a negative. So that's all negative. Between negative 14 and negative 2, I'm going to do negative 3. So that would be positive over negative, negative. So this would be positive overall. Between negative 2 and 1, how about 0? So we have positive over negative, positive. So that's negative. And then to the right of 1, we have positive over positive, positive. So that would be, we want to know where this is less than or equal to 0. So where is this negative? Where this is negative is from negative infinity to negative 14. And we are going to include negative 14 because we can be that. Union between negative 1, negative 2, and 1. But notice that we can't be either of those. So that's negative 2, comma, positive 1. And then both of those are brackets because we can't be them. So those are inequalities. I think these are far easier than doing graphing or all the stuff we did before. Hopefully level 4 has treated you well, and this is the last video of the calendar year. So good luck studying.